So in these problems, we are going to continue to be doing compositions that involve inverse trig functions. And so the problems in this topic, just like the last topic, we're going to have to actually evaluate some parts of it. So for example, find the exact value of, so the cotangent of the inverse sine of negative 5 over 8. Okay, so negative 5 over 8 is not a value on the unit circle, so I'm actually going to have to do a little bit of work here. So what I'm going to do, we'll call this part A because we'll do another one, is I'm going to let this inside stuff here be theta. So I know when I take the inverse trig function of a value, I end up with theta. I get an angle, so that's why I'm calling it theta. So what we're really saying here is that theta is equal to the inverse sine of minus 5 over 8, which means that the sine of theta equals negative 5 over 8. Now, the inverse sine is only defined in quadrants 1 and quadrants 4. So since we're dealing here with a negative, that's telling us that we must have an angle that is here in quadrant 4. So I'm going to draw this reference triangle, and I know the opposite, negative 5. The hypotenuse here is 8, and we can use Pythagorean theorem to find the missing side. So a squared plus b squared equals c squared. So a is, we'll say a is the one we don't know. So a squared plus negative 5 squared equals 8 squared. So a squared plus 25 equals 64. And then a squared, if I subtract 25 from both sides, I'm going to get 39. So a is going to be plus or minus the square root of 39. And because we know we're sitting here in the fourth quadrant and we're going this way, we know that a is going to be the positive. So square root of 39. So my problem right now turns into I am looking to try to find the cotangent of theta. And the thing to remember is that we drew this picture here based off of theta. So we drew the reference triangle for theta. So the cotangent I can just read off of my picture. So remember, cotangent is adjacent over opposite. So that's going to be the adjacent, square root of 39, over the opposite, negative 5. Or you could write it as just minus square root of 39 over 5. So we'll do one more here. So for example, the cosine of the tangent inverse of negative 2. So again, just like in before, I'm going to let this stuff inside here be theta. So we're saying that the tangent inverse of negative 2 equals theta, or that the tangent of theta equals negative 2. Again, the inverse tangent function is defined in quadrants 1 and 4. And so since we're dealing with the negative, we're going to be dealing with quadrant 4. So I have some angle in here. This is theta. The tangent is the opposite, negative 2 over the adjacent 1. We'll use Pythagorean theorem to find the missing side. So a squared plus b squared equals c squared. So 1 squared plus negative 2 squared equals c squared. So this is going to be 5 is equal to c squared. So c is going to be equal to plus or minus the square root of 5. Since the side that we're missing that we just found there is the hypotenuse, it's going to be positive. So it's going to turn out to be the square root of 5. And so this problem boils down to actually trying to find the cosine of theta. And if I read that off of my reference triangle there, the cosine is going to be 1 over the square root of 5.